Hi guys, welcome to lesson 12.7, Theoretical and Experimental Probability. This is the penultimate or second to last lesson in algebra this year. Our objective for today is that I can find theoretical and experimental probabilities. We have a couple vocab terms to go over. First of which is outcome, which is the result of a single trial. Sample space is all of the possible outcomes you could have. An event is any outcome or group of outcomes, and probability is how likely it is that the event will occur. Our essential understanding: the probability of an event tells you how likely it is that the event will occur. You can find probabilities by reasoning mathematically or by using data collected from the real world. All right, so problem number 1, finding theoretical probability. So this is the number of favorable outcomes divided by the number of possible outcomes. So our first question is, you are selecting one of the 8 planets in our solar system to write a report about at random. What is the theoretical probability that you will choose Mars? Well, out of the planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, Uranus, there's only one Mars, right? So the number of favorable outcomes is 1, because that's all Mars is. The total number of possible outcomes is the total of 8 planets, so it is just 1 over 8. Letter B. The planets in order from the Sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. What is the probability that you will select a planet whose distance from the Sun is greater than or equal to Mars? Well, if these were in order, so Mars is greater than or equal to Mars, so is Jupiter, Saturn, Uranus, and Neptune. So that's 1, 2, 3, 4, 5 out of 8. It can sometimes be written as 5 of 8, 1 of 8. Okay. So Christy spins the game spinner below. What is the probability that she spins less than a 4? Well, what numbers are less than 4? 1, 2, and 3 are all less than 4. So that's 3 favorable outcomes out of a total of 10 possible places that you could land in the game of life. All right. Moving on to the next page, problem 2. Finding the probability of the complement of an event. Now, the complement of an event is all of the outcomes in the sample space that are not in the event. The sum of the probability of an event and its complement is going to be 1. So, a final exam contains 15 multiple choice, 10 true or false, 10 short answer, and 5 multiple choice. If you choose a question at random to review, what is the probability that it is not multiple choice? So this would be the complement to multiple choice. It would be everything but multiple choice. So that would be true or false, short answer, and essay. 10 plus 10 plus 5 out of our total probability or total outcomes, which is 40. That's 25 over 40, which can reduce to 5 over 8. Okay. Finding odds. Odds describe the likelihood of an event as a ratio comparing the number of favorable and unfavorable outcomes. So odds in favor would be the number of favorable over the number of unfavorable. Odds against would be the number of unfavorable over the number of favorable. Okay, so what are the odds the spinner lands on a number less than 3? Well, the numbers less than 3 are 2. The numbers that are 3 or greater, 1, 2, 3, 4, 5, 6, which reduces to 1/3. Again, we can write this as 1 to 3. There's a 1 to 3 chance that you're going to get a number less than 3. Okay. What are the odds against a spinner landing on a number greater than 5? Well, greater than 5 would be 6, 7, and 8. What are the odds against it? So it would be unfavorable, so it would be these others, which would be 5, over the favorable, which is 3. We could also write it as 5 to 3. Now, where do we see something like this, odds in favor, showing up in the real world? Well, we're going to call this an adult spinning wheel. Otherwise known as roulette. That's probably one of the most clear examples of just calculating odds in the real world. Yeah. All right. Finding experimental probability. Experimental probability is based on the data collected from repeated trials. So the probability of this event is the number of times the event occurs divided by the number of trials that you conducted. So a skateboard manufacturer inspects 2,500 skateboards. There are 2,450 with no defects. What is the probability that a skateboard selected at random has no defects? Write this as a percent. So the number of times the event occurred, which would be 2,450, over the number of trials, 2,500, and that's going to be 0.98, which is 98%. Letter B, in a survey on favorite pets, 28 people chose dogs, 15 chose cats, boo, 4 chose birds, and 3 chose fish. If a participant is selected at random, what is the probability that they prefer dogs as a pet? So, the number of times the event occurs would be how many people picked dogs. So that would be 28. Out of our total, so 28 plus 15 plus 4 plus 3 is 50. So 28 over 50 is 0.56, which is 56%. So you have a 56% chance, so just over 1 in 2, of picking somebody out of that survey that chose dogs as their favorite animals. All right. Problem number 5, using experimental probability. So this would be the application side of experimental probability. Now, a manufacturer inspects 700 light bulbs and finds that 692 of the light bulbs work. There are about 35,400 light bulbs in that manufacturer's warehouse. About how many of their bulbs are likely to work? So let's just start by figuring out what the percentage of working light bulbs are in our experiment. So we have 692 that were favorable, or that met the criteria out of the 700. So that's 692 over 700. That's going to give us our percentage of light bulbs that work in our sample. Now we want to multiply that by the total number in their warehouse in order to find how many of the bulbs in the warehouse are going to work. So we're using our experimental probability that says that approximately 98.86% of these light bulbs work. We're going to multiply it by the total number of light bulbs we have to figure out approximately how many of those are expected to work. And that's going to be, with rounding, 35,995. 35,995 working bulbs. So out of their 35,000, wait, that's not right, because that's more than what we have. So let me check my work. So we do 692 out of 700, multiply that by 35,400, and we get 34,995. Miswrote that. And it's 0.42. Can we have 0.42 of a working light bulb? No, we can't, so we're going to round down. So approximately 34,995 of their light bulbs are going to be working. All right. Now, looking at the second one, the quality control worker samples 500 LCD monitors and finds cosmetic or appearance defects in 3 of them. If a company manufactures a run of 12,000 monitors, how many would you expect to have a cosmetic defect? So in this case, our experimental probability is 3 times out of 500, our monitor had some kind of defect, whether it was a scratch or colors weren't quite right, some kind of cosmetic, not functional, but cosmetic. And if they're making 12,000 of them at a time, well, we multiply times 12,000. All right, now 3 divided by 500 times 12,000 is 72. So we would expect to have 72 defective monitors. Now, this is the kind of analysis that a company is going to do. They're going to look at a random sampling from their assembly lines, and they're going to test them, and they're going to look for every possible factor, every possible variable that their product can have. And if they are seeing that too much of their product line is defective, they need to shut their product line down and check to see where along the process something is going wrong. Some machine might be out of alignment or something. Something is not going right. So this is a very realistic application of this kind of probability. All right, so there you go. Fill out your level of understanding. Write down any questions or confusions you may have from the lesson, and make sure you write a summary of what you learned about finding probability, both theoretically and experimentally. All right, that's it for today. Have a great night.